Welcome everybody to this Galloway Glens event, Can You Dig It? 3D Galloway, LIDAR for Archaeological Survey. Really interesting one this week. Some of your old hands, we have got some new faces, so I'll just do the usual run through the Galloway Glens. It's a 5-year heritage lottery scheme funded from 2018 to 2023. So we're just past our halfway point actually. The purpose of the scheme is to connect people with their heritage, natural, cultural and built heritage. For those of you who know where we are, the Galloway Glens is in southwest Scotland. It's really very rural southwest Scotland. For those of you who do know, it stretches from Carsfen and the Glen Kens in the north, past beautiful Loch Ken, out to Castle Douglas and out to the sea at Kirkcudbright. It's looking its autumnal best at the moment. We've got 35 projects happening with various different partners over the 5 years, and one of the most important ones really is Can You Dig It? In partnership with Historic Environment Scotland. So we're very grateful to them and the National Lottery Heritage Fund for their funding, which lets us put on these events. Can You Dig It? Is a community archaeology project aimed at connecting people with their built heritage of the area, which, as any of you who follow our social media streams or have been attending these events will see, though, we've got a fascinating built heritage and in the area. So this is the I don't even know how many events we're in now. The next in our series of events. And we're delighted to have Dave Cowley from Historic Environment Scotland joining us. Now, Dave, internet is not great, so he may remain a mystery to you all, but his audio is good, and that's the main thing. And obviously, we've got some slides. Dave's an archaeologist at Historic Environment Scotland, working in a survey team to develop methods for using remote sense data, including LIDAR, or airborne laser scanning, effectively. He's been surveying Scotland's landscapes for 30 years, from the ground, in the air, and using remote sensing. He's interested in all sorts of things, including Iron Age settlement, but his main focus is on how the landscape has come to be the way it is today, and how we can read that landscape to see what people did in the past. So absolutely fascinating, and a new way of looking at our landscape. Dave will run through his presentation in a minute with Claire. I should have said welcome to Claire Williamson. You all know Claire by now, senior archaeologist at Rathmell Archaeology. You can have a bit of chat if you like in the chat. If you don't like the chat box, just minimize it. You don't have to look at it if you find it distracting. And then we'll run through Dave will do his presentation, and then we'll run through the questions at the end and put them to Dave. And you can get to mine Dave for his experience. So I think, with no further ado, I'll stop screen sharing and hand over to Dave Cowley of Historic Environment Scotland. Oh, you might find you're best off on speaker view, for those of you who are new to Zoom. Okay, Dave.
Good evening, everybody, and thank you to the Galloway Glens Landscape Partnership for the invitation to speak to you. And I can honestly say I don't think I've spoken to so many parts of the world at the same time in the past. Welcome everybody. So 3D Galloway, LIDAR or airborne laser scanning for archaeological survey. What I'm hoping to do over the next kind of 40 or so minutes is to give you a little bit of background to what LIDAR is, some of the ways it's structured, and look at some applications. Some of the work that we've been doing at Historic Environment Scotland, and then bring it back down to Galloway in thinking about how LIDAR might help people connect with their landscapes, as Helen was saying. Next slide, please. So I guess that you would probably have to have been under a rock over the last 5 or so years not to have picked up some of the, I was going to say hype, but some of the news items around LIDAR from everywhere from Central and Southern America through to Southeast Asia and all across Europe. Airborne LIDAR has kind of exploded on the archaeological scene and has made some very, very significant contributions to archaeological knowledge. The team, for example, that's been working at Angkor Wat for best part of 3 decades, doing very painstaking mapping in the rainforest, found out that with a single LIDAR acquisition, they had more data, more information, more mapping than they'd secured with 25 odd years of stomping around on the ground. And that's extended to Scotland. We were in the news a couple of years ago with the discovery of lots of new archaeology on Arran. And there's also been people taking advantage of or using their time in lockdown to explore LIDAR very, very effectively. So, what is it? LIDAR and airborne laser scanning are one and the same thing. In a nutshell, it's a box of tricks mounted underneath an airplane, which you're seeing at the top right there. And LIDAR stands for light detection and ranging. I prefer airborne laser scanning because it's one of those things that says what it is on the tin. And essentially, it's an active technique where a laser mounted below an aircraft sends out pulses in a scan position in really quite high numbers, anything up to 200,000 pulses per second. And essentially, those pulses hit things, trees, buildings, the ground, and that pulse is then reflected back to the sensor on board the aircraft. And this relies on satellite positioning, various bits and pieces in the aircraft, and some post-processing to provide dense, precise, and accurate terrain models, which is essentially why we as archaeologists are so interested in it. And you see there at the bottom that visualization giving you an idea of one of the things that really has attracted people's attention with LIDAR, that the magic of being able to strip away the vegetation. That's an example in Austria, which is simulating the capacity to see through the trees. Next slide, please. So just give you a little bit of an idea of how that might work in practice. Essentially, pulse out of the aircraft is fired downwards, and it can hit and be reflected back up to the sensor in the aircraft off branches, leaves, and the ground. And the image of the green tree with the red dots on it is a piece of work that Austrian colleagues did a few years ago, where they did a terrestrial laser scan from the ground to capture a tree, and at the same time an airborne laser scanner was deployed. And that's essentially to give you an idea. The red dots are the points of reflectance from the airborne laser scanning. So you're seeing there that under the tree canopy, really quite a lot of points essentially are getting snagged on the canopy and not being and not reflecting the ground surface underneath. And that's one of the things which I think is worth kind of keeping in mind as we think about how we use LIDAR. I think it's when you're using a technique, whether it's aerial photography or excavation or whatever it is, it pays to understand the processes and the character of the data that you're working with. And what I want to do in the next few slides is to have a look at some of the characteristics of LIDAR, going across the capture side of things, the processing of that data to produce things that we can work with, and then the multiple visualizations that we use as our raw materials for mapping. And the one crucial thing in all of that is that we're not in the business in archaeological survey using LIDAR of producing pretty pictures. What we're actually looking for at the end of the day is interpretive mapping that helps us to understand what people have done in the past, their material remains, and to create narratives around that. And quite often you'll see that the wow images derived from LIDAR, they are pretty pictures. There is a huge amount of work that then goes into the production of archaeological knowledge from that. I put a very basic image up there from some very outline mapping of a landscape on the west side of Skye, and some people wandering around on a typical sunny Skye day at the bottom there, essentially to make that point that LIDAR or whatever data sources we're using work in tandem with other approaches to interpretation, and ground observation for all the richness and power of the LIDAR visualizations remains a really important element of that. So, LIDAR, airborne laser scanning, at its very, very basics, it is producing what we call a point cloud. So essentially, points where the laser pulse has hit something and bounced back, and it creates the processing creates a point cloud XYZ, which gives us coordinates in space. And what you're seeing there in the single graphic is essentially a cross section that has the ground points in greenish colors, and then the trees, the canopy above. And the two images, one on top of the other, essentially illustrate again that kind of magic thing which captures everybody's attention with LIDAR, that capacity to strip away the trees. This is an example from just outside Vienna, again in Austria. And what we're looking at the top is a surface model. So this is the tops of the trees where the laser pulses have bounced back off branches, leaves, and so on. And then the bottom image is where that's all been stripped away to reveal that archaeological landscape. And you're seeing there the very nice remains of a medieval monastery and castle sat up on the top of the hill there. So this set of images here is really to make the point that you will hear people talking about how LIDAR sees through trees. No, it doesn't. It relies on laser pulses being able to penetrate the canopy and get to the trees and get to the ground and be bounced back. So general rule of thumb is if you can stand underneath a bit of vegetation and keep dry, then probably LIDAR, airborne laser scanning, will not penetrate down to the ground. So leaving aside the owl chicks, a lot of the very dense coniferous forestry, for example, which we have in parts of Scotland, the canopy is just simply too dense to allow laser pulses to hit the ground and be bounced back. And that's illustrated in the image, the long tall image, which is a part of Kilmartin Glen in Western Scotland. And essentially all of those areas that are coloured red are areas of very dense coniferous forestry where there are no ground points. So it's an important factor to remember that essentially anywhere where you're working in open ground, you will get much denser point cloud and much better visualizations. Anywhere where there is any form of canopy, above ground vegetation that can diminish the number of laser pulses hitting the ground and getting bounced back, you will lose resolution, if you like. So another aspect of that, as the next slide comes up, is that airborne laser scanning is not just airborne laser scanning, but there are a whole series of things that can affect its resolution, its quality, its clarity. And one of these, for example, is what time of year it's been captured. And here 2 laser scans of the same post-medieval farmstead, taken a month or so, a little bit more than a month or so apart. And the slight, oh, I've put those 2 grayscale images the wrong way up. I apologize. Something had to go wrong. So you will see that the ground photograph with all the nettles and stuff grown up that's labeled May belongs with the image diagonally up from it. And you can see how the close to ground vegetation, like the nettles, essentially has kind of defocused and fuzzed down the image, in contrast to the much sharper one that belongs with its diagonal taken in May. So a lot of the LIDAR available in southern Scotland, for example, was captured in April, May and June. And you can see in some areas, next slide please, where the things like bracken growing up have reduced the quality of the digital surface model. And one of the other things to keep in mind is that the processing of that data from its, what we would call raw data, the point cloud, this kind of constellation of points, into things that we can use, is also a relatively complex issue that can bring with it problems, limitations, issues. And the 2 images that you see at the top, the grey one, you've got there in the more or less in the middle, a circular feature. It's about 8 meters in diameter. This is on Arran. This is the kind of signature that you would get from the footings of a prehistoric roundhouse. And that's kind of what I thought it was when I first looked at it. However, the other image, level with it, is an ortho photograph, which shows that there is the most enormous boulder sitting in the same location. You can see a slight shadow at the top of it. And what's happened here is that the processing that has been done to filter out what the algorithm thinks is above ground vegetation has identified this great big rock, pulled it out, and left a void in the data which has been interpolated to produce this very nice roundhouse. It's just an artifact of processing. The series of images at the bottom illustrate another of these issues, which relates to the fact that LIDAR, airborne laser scanning, is obviously collected in strips, and you can see the north and central bit of Arran there to illustrate, and you see the grain across that where the flight lines have gone. And one of the crucial things to do here is to adjust between the strips. And the example of the 2 grayscale images, the central one shows a whole load of kind of sort of pitted, mottled surface. And this is not a real reflection of the terrain. It's rather a reflection of poor strip adjustment. And when done correctly, that process of strip adjustment between these 2 overlapping flight paths produces a smooth surface. So next slide, please. There's devil in the detail, I suppose, is the main point that lies in those slides. And resolution, if you remember back to one of the early slides, airborne laser scanning systems may vary from systems that produce 30,000 pulses a second to 200,000. That has an immediate relationship, depending on flying height of the aircraft, into the density of the point cloud and all of the derivatives. So you've got on the screen in front of you 2 images of the same piece of landscape in Kilmartin Glen, reflecting 2 different data sources of airborne laser scanning at different resolutions and different filtering. So really quite dramatic differences in what you can see. Next slide, please. So I suppose the message of that was if you're going to use LIDAR, you need to understand some of the basic characteristics of the processes that you're going through in order to avoid some pitfalls and which may compromise your interpretation. And I wanted to move on from that to the production of the images, the pictures, LIDAR pictures, which are the main mechanism that we work with the data at the moment. And as an archaeologist, being out on a crisp February day with low raking light that throws all the little humps and bumps and undulations into high relief is an enduring pleasure. Leaving aside that you're not going outside, the most fundamental power of the airborne laser scanning data is that capacity to not only to manipulate the light, but also to process the data through into visualizations which go beyond just simple lighting. So the two images in grey are a hill fort, and essentially you're seeing different elements of the topographic features there, which are dependent on the direction of lighting, and you can play with this interactively. The kind of scary looking image, other image there with all the multiple colors set across 3 grids. This is a series of fairly standard now outputs from something called the Relief Visualization Toolbox, put together by some very clever people in Slovenia, which takes the same data set, the same digital surface model derived from the ALS point cloud, and processes it in all sorts of different ways. And I'm not going to go into the nitty-gritty of that, but this moves us beyond the mimicking our capacity to see, which is dependent on things like highlights and shadows, which, for example, aerial photography relies on, into really very, very different ways of visualizing topographic features, for example, based on the level of exposure of individual pixels to the hemisphere. An incredibly powerful different ways of looking at the data. Next slide, please. And again, as with the processing, one of the really crucial issues is to understand what you're looking at. Looking at images without a understanding of how they've been produced, whether that's shadow or other means of visualization, is always going to weaken your interpretation. Now, recognizing that multiplication of different visualizations of the same data sets brings with it enormous complexity, what's called the multi-direction hillshade has become quite popular. And this is essentially trying to escape from the fact that an image lit from a single direction will always suffer from features that lie along that line of lighting disappearing, which we saw in one of the earlier slides with the hill fort. So essentially this is about combining multiple directions of lighting in order to ensure that features, regardless of what their alignment or orientation is, become visible. And it's a very, very powerful tool, which also feels probably quite familiar to most of us because it mimics how aerial photographs, which all of us are used to seeing as a matter of routine, visualize. And in practice, this is another example of from Arran at Tormore, just to the kind of west of Macrymore, for those of you who know the area. And when we're undertaking archaeological survey, we're tending to use a combination of these, the hill shading that I've just been talking about, something called local dominance, sky view factor, openness. And The main point I want to make is that between those 4 different visualizations, we're seeing different types of information. And this is really about trying to squeeze the pips out of the information by viewing the same data in multiple ways. There's no question for me as an archaeologist that LIDAR and airborne laser scanning really is a game changer. And it's probably on the scale of what aerial photography produced in the mid-20th century. It's something we're now incredibly familiar with, aerial photography is. Next slide, please. But for archaeology, what airborne laser scanning is doing for us is absolutely incredible. We're not as well served at the moment as some countries in the extent of our coverage, which you see in the 2 maps, one on top of the other, but it's growing. The quality of the data is really, really great in many cases, especially across southern Scotland. The image that sits by itself on that "it's a game changer" slide is a relatively small area of Stregeeth Roman fort. I think it's probably about 300 meters by 200 meters across. And it took a colleague and I the best part of 3 days to collect this using an electronic distance measuring theodolite about 15 years ago. And that quality of data, that intensity of height data is now routinely available across the whole of Scotland. So what this data, however, does beg a question or a series of questions is about how we work effectively with it, where our efficiencies are, how we combine digital and manual, and how best we can use this data to improve our knowledge of Scotland's past. So that's the background against which Historic Environment Scotland set up a team. The 4 people that you see in front of you there, Kirsty Milliken, Lukasz Banaszek, George Geddes, and myself, to do a research and development project, essentially to explore how we should be using this data to expedite very large area survey. You can go down one now. Next slide. How we undertake large area survey, and to think about how we address landscape scale. The Rapid Archaeological Mapping Programme, the other things we wanted to have a look at are about scoping the potential of artificial intelligence and encouraging the contribution of citizen science. And just a word of advice, if you're setting up a project and coming up with an acronym, road test it through Google Translate. So I have a lot of Dutch colleagues who've found the idea that I work in a RAMP team, which is Dutch for Flemish for disaster, highly amusing. So always check that out first. So I just want to spend a couple of minutes talking about what we've been doing in this project. Next slide, please, which should be about major land use changes coming. And essentially one of the drivers for what we're trying to do here is how do we leverage this digital data sets that are becoming more and more widely available, really to expedite the upgrade of our knowledge about Scotland's historic environment and landscapes. And this is in the knowledge that everywhere where we do systematic survey, we can expect between 50% and 200% uplift in the number of monuments that we know about. And, you know, with the Scottish Government's commitment to addressing the impacts of climate change, for example, trees are likely to be planted big style across the landscape. And in this context, it is, you know, in my view, better for archaeology to be on the front foot and engaging with that process rather than reactive. Next slide, please, which should be about the projects that we've done, beginning with Aaron in 2018. I've just put up this to show you the 3 main projects that we've done as part of this research and development project. and to highlight the significant number of new discoveries. For example, we've made on Arran, which is really quite a well-known part of Scotland archaeologically. We roughly doubled the number of known monuments, including quite significant ones. Kilmartin repeated that pattern, and in the Whitadder in the east of Scotland, we've dealt with, between new discoveries and the revision of existing records, approaching 2,000 monuments. So I hope that speaks of, first of all, the benefits that the LIDAR brings through in terms of discovery, but also those relatively rapid rates of coverage. The other thing that I wanted to highlight is that in both Arran and Kilmartin, I don't have the figures for Whitadder yet, but you know, in the order of 20% of the monuments that we found were found through field investigation. So again, that's making a point about the importance of an integrated approach and not expecting airborne laser scanning to do everything. Next slide, please. And here, just a little bit of detail with two maps of site distributions on Arran, prehistoric hut circles, and medieval and post-medieval shieling huts. And this is about, even in a relatively well-known part of Scotland, major significant uplifts in what we know about the past. And the bottom line is, if that can happen on Arran, in Kilmartin and Whitadder, that pattern will repeat itself across the rest of the country. Next slide, please. And those discoveries on Arran include nationally important monuments. The two parallel lines that you see with the red arrow beside them, we believe, are the slight earthwork remains of a Neolithic Cursus monument. There's about, depending on how you count them, 4 of these surviving as earthworks in Scotland. Incredibly rare and largely unexpected on Arran. Next slide, please. And as part of this RAMP project, we've also done a little bit of sampling across the wider landscape, and the map, or the LIDAR image with the red and blue dots on it, this is an area of 10 kilometers by 10 kilometers near Stow in the eastern borders. And all of the red dots represent new discoveries from a day spent trawling around on the airborne laser scanning visualizations against the distribution of already recorded sites. So you're seeing there a day's work producing a significant improvement in our knowledge of the distributions of archaeological monuments. And just to give you an idea of the types of monuments that have been popped up here, the image at the top is the earthworks of a medieval village which was cleared sometime around 1700 in the grounds of Mertoun House, not far from Melrose, beside the Tweed, essentially to create an area of nice parkland. But you can see, I hope, the arrangement of the streets on either side of a central green and the pattern of the fields going into the background. These kinds of medieval village earthworks are relatively common in parts of northern England, but are relatively poorly known in Scotland. So this is quite an exciting discovery. The two images at the bottom illustrate a ploughed out circular enclosure, probably Iron Age in date, possibly a Brocksmith, Lindsay, if you're listening. And a late Iron Age, Roman Iron Age period set of enclosures, again near Stow. Next slide, please. And I've highlighted new discoveries in those images, but the other thing that is popping out of the airborne laser scanning is the insights that it provides to really well-known sites. What you're seeing there in front of you is the temporary camp on the south side of Burnswalk Hill, for any of you who've driven northwards along the M74 and don't know the site, that's the flat-topped hill that you see when you're approaching Lockerbie. And this is one of the first archaeological monuments to be recorded archaeologically in any way during the late 18th century, and is being visited by virtually every archaeologist in Scotland, probably. And most of them will approach the site coming in at the bottom of the screen beside the slightly burnt out bit, which is the coniferous plantation, and walk up from the gate there through the edge of the red circle that I've put there. And I hope that you can see in the middle of the red circle a square enclosure. This popped out of an examination of the airborne laser scanning. And this is a site that has been walked across, looked at in really quite a lot of detail for however many hundreds of years. But it's relatively slight. You can see it when you know it's there on the ground, but popped out of the visualization there. So as well as those kind of new discoveries, new light on apparently well-known sites. Next slide, please. And I've put this image of Macquarie Moor up really to identify how effective, or illustrate how effective, the airborne laser scanning data is in removing some of those kind of vegetational problems. Anybody who's wandered around in this part of the country to the south of the Standing Stones will know that it is pretty hard going. We were there in the summer. Okay, so there's lots of bracken, but this is pretty hard to see archaeology on the ground, and the LIDAR produces remarkably consistent and relatively neutral visualizations. And I said that one of the things we were trying to do with the RAMP project was to think about how we do survey. And one of the things that has emerged from the work that we've been doing is the extent to which we can generate quite detailed characterizations and information from the airborne laser scanning. So we're back on Tormore in Arran. At the top, you see a small roundhouse with a series of probably agricultural clearance cairns round about it. Because this is three-dimensional data, you can draw cross sections across it. You can get real height values. You can get accurate measurements. And what I've done with the text there is to take the description written by somebody called Tim Gates, an Ordnance Survey archaeological surveyor who visited the site in 1977, and highlighted in red the only bit of information that actually required somebody to be there on the ground. So this is not about diminishing the importance of going and visiting stuff on the ground, but it's about identifying, perhaps being a bit more targeted and strategic about why you want to go and visit something on the ground, and also maximizing the information that you can get without jumping in a car, polluting the planet, and spending 2 days doing it. Okay, so this is rich information that are explored in the right kind of way. Yes, indeed, an orthostat is an upright stone. So essentially about identifying what you can get out of this data. Next slide, please. What we've also been trying to do, which is partly about that process of thinking about how we do what we do, and not just taking the way we used to work in an analog world and translating it in and forcing that onto a digital environment, thinking about how we work. And one of the things we've done starting on Arran and running through all of our subsequent projects is to try to document as much as possible the survey process to give people a deep understanding of how we created that information. So for example, we had multiple the image at the top shows the outputs of multiple interpreters working in the same location. So we're trying to explore how people see things differently. The image at the bottom shows different patterns of discovery, desk-based fieldwork, but we also recorded all of the tracks of where we walked, so that again, people could see the bits of the landscape that we did and didn't inspect, and they can ask the question why. Next slide, please. And just to illustrate a little bit of that, my experience of field observation, air photo interpretation, so on, is that we do all have subtle differences in the way we see the same features, and I find that very stimulating. It's a very interesting way of shining a light back onto how you yourself see, to have somebody see something differently. And we explored this a little bit in detail on Aaron, and with the image, the smaller of the two images, essentially you've got the outputs there of three different interpreters, A, B, and C, and you'll see immediately that they identified different features, they split them down or grouped them in different ways, and they assigned a different level of confidence to that interpretation. Okay. As an archaeological surveyor, I find this kind of stuff fascinating because it's the kind of nuts and bolts of how the aggregated archaeological survey record represented by something like Canmore has been created. Next slide, please. This, I think, is probably my most scary slide. It scares me. But this is, and I don't want anybody to dwell on the terribly complicated diagram on the right-hand side, but essentially this is a visualization of the cradle to grave digital workflow that we've developed, which is about ensuring that we work from data download with systematic information monument types, for example, that data creation can happen in one element. There's a quality assurance loop. And at the bottom of it all, or at the end of it, a simple comma-separated file, text file, is exported, and it's presented to our database, the National Record of the Historic Environment, what you see through Canmore, and all of the creation of the site records and all the metadata, all the background information is done automatically. Okay, so this is about taking a process where when we used to finish a survey, we would spend at least as long as we'd spent in the field, if not twice as much time, manually rekeying everything. Okay, we've done away with all that and produced an automated system that ensures that we're being systematic and that we are not manual handling anything that we don't need to. And I mentioned this as part of the overall aspirations of RAMP, which was to see whether we could progress anything in delivering data and basic recording form to mobile devices to facilitate citizen science. We did a little trial on Aaron, which was forced on us because hideously bad weather broke a few of our pen computers. So we ended up having to try to work off our mobile phones. And this is unfortunately an area that's not that well developed, but I'll come back to towards the end. The final element of the project that we're working on is really looking at how artificial intelligence, machine learning, and so on have the potential to help us with archaeological survey, that basic process of detecting archaeological monuments. And the images that you're seeing in front of you are from the work of Iris Kramer, a PhD student at Southampton. And I don't know how well you can read that, but the colored squares have both a classification, roundhouse, small cairn, shieling, and also a number beside it, which is the probability between 0 and 1. So 1 being the algorithm, the computer is absolutely certain this is an X or a Y. And I think that's really pretty impressive. I think if I could do that every day of the year, I would be quite pleased with myself. So identifications are pretty good. Classification is slightly more less reliable. But what this demonstrates to me is that in working through how we do archaeological survey of massive areas like the whole of southern Scotland, that something like artificial intelligence has demonstrated its capacity to move things forward. And I mean, here's a fun little illustration again from Aaron with two images, one on top of the other, which are titled "The People," and the top one is a desk-based identification, which said an enclosure with a medium level of confidence. I'm not sure. Maybe it is. Maybe it isn't. Two of our field survey team went and visited it. You can see the GPS recorded tracks of them walking around on the monument, and they dismissed it as natural. Iris's neural network came back with a pretty high score, thinking, 0.97, that this was a roundhouse with a lesser probability that it was a shieling or a small cairn. Having got this back, I did a little experiment with colleagues as they came into the office back in the days when we had people in offices, and said, "What do you think this is?" And all of them said, "Oh, it looks like a roundhouse, a hut circle." And we haven't had a chance to go back and have a look and see what we think about it. But I think this is a fascinating example of how you can work with something like an AI. It's not about that, Dave's right or the neural network is right, or that people are. It's not as simple as that. But actually, just to explore the data in a different kind of way. And it's certainly pretty difficult to dismiss that there does seem to be something round in there. So for me, a really, really potentially productive way forward. Next slide, please. And in the background here, there is, you should be seeing a slide with Norman, the based on Norman Bates out of Psycho. And we're learning much more about how to work with AI. And I like this example at the top, which is an example of two standard AIs, one of which was trained on something called the dark net, which I'm assured is full of all sorts of unpleasant stuff, and another one which was trained on pictures of puppies and kittens and kind of nice views of landscape and so on. And they then created these blot ink pictures and asked the AI basically, what do you think this is? Label it. And you see the two different interpretations there. And I think this is pointing to a factor which is illustrated by the bar graphs at the bottom, which was a project by an MSc student at Edinburgh, Hassan Al-Mahroun, who used the Aaron data and put it into, I think, 18 different neural networks and tested the performance. And the different colors of the bar charts there are essentially identifying different levels of performance. And so what we're learning here is that, there's no such thing as an AI. There are probably neural networks that are better archaeologists than others. And again, that is a really fruitful line of interpretation, which, for example, begs the question with digital topographic data like airborne laser scanning. We turn these dense point clouds into a visualization because we need to do that in order to be able to see it. A neural network doesn't need to do that. When we take a dense point cloud and turn it into a visualization, we reduce the dimensionality, the richness of that data to suit us. So there's a question there, actually, are we doing the right thing by reducing that data dimensionality, that richness of data? Next slide, please. And I'm pleased to say that we're developing this in specifically Scottish context. Lucy Killoran has just started a PhD at Glasgow University on asking the question about how we integrate artificial intelligence into practices of archaeological landscape survey. And this is a collaboration between HES, Rachel Opitz in archaeology, and Paul Siebert in computer science. And there's a series of things that she's going to be looking at. But this is a tremendously exciting development for us in being able to try to design something and build something that works in a specifically Scottish context. Next slide, please. So 4 images on your screen. In all of that, it's not could you click on again, please? That's it. This is not a kind of learning outcome from the RAMP project because it's kind of self-evident. But one of the things that working with the remote sense data you come back to again and again is that there is absolutely no substitute for landscape knowledge. Consistently, the sources of poor archaeological interpretation of remote sense data are a lack of that knowledge. And this is one of my favorite examples, that in the gray image at the top, you have a series of little kind of round things, which you could be forgiven for interpreting as little barrows or little roundhouses or something like that. And they're not. They are the little earthworks left behind by cattle feeder bin stations where, stock have crowded round, in the top case, a circular cattle feed bin stance, and created this kind of earthwork of puddled and heavily manured ground. And the point about that is that even if you don't know what the features that you're seeing in the airborne laser scanning visualization are, the ortho photographs with the pattern of tractor marks and the heavily improved ground give you that information that these things are highly unlikely to be of any antiquity. And that's just a little slightly trite example of how that kind of comprehensive, wide view of the landscape now and how it's come to be the way it is an absolutely fundamental element of working with this type of information. Because aerial photographs or airborne laser scanning capture everything from the day on which the imagery was created back into the past. And really quite a lot of the information that's in there is about relatively recent land use. Next slide, please. So, what about Galloway? I just wanted to show you a couple of examples of what's popped out of the data recently. It's such a good time waster. I've spent a lot of time on this when I should have been doing much more worthy things that my boss told me to do, but hey ho. So this is near Newton Stewart, Calgow. You see the orthophoto there, the rough position of this, presumably later prehistoric fortification, obscured by trees. I suspect most of the year almost impossible to discern on the ground, almost certainly covered in bracken and all sorts in between the trees. But here you've got a not insubstantial monument, 100 meters by about 40 meters within a pretty chunky rampart. So a nice addition to the corpus of later prehistoric fortifications in the West, which are notable for their sparsity in that particular part of the world around Newton Stewart. Next slide, please. This is an image of the Skyer Burn, and this is one of the areas where airborne laser scanning is going to be particularly powerful. This is quite a heavily improved field. The orthophoto that you see on in green has got a grass crop on it. You can see that actually it's in the process of being cut, but it's also been ploughed for cereal crops in the past. Although that may be a cereal crop. Anyway, it's got grass, I think grass on it in the color photo. And what we're seeing there is on the gray image, the incredibly ploughed out remains of a ditched enclosure. I don't know what it is. it sits quite close to the Roman road, which I thought was quite interesting, but that may be a red herring. And the striations, the corduroy pattern that you're seeing across it, there is grass that's been cut and is sitting there waiting to dry. So again, that thing about aerial photographs and LIDAR capture all sorts of things, and that's one of the reasons why I find them so fascinating. So this is within an area that I did a survey of in 1992, I think, and I missed it, and I would miss it, a monument like this, every day of the week, because if I walked across it, I would be lucky to register that there is a slight depression, and my capacity at ground level to appreciate that there is a circular ditched enclosure is almost zero. I can say that it's about my an area I did survey of, but I think that's going to be a very repetitive pattern of these kind of very subtle, difficult to discern monuments, which don't tend to come through in the aerial photography either. Next slide, please. And as I'm kind of starting to round up, I just wanted to bring us back into the Galloway Glens. And what you're seeing there on the screen is the roughly 1,700 known archaeological monuments spread out across nearly 700 kilometers squared. This is a relatively densely surveyed or known part of the world, but you can see that there are places where the distribution's thin a little bit. And next slide, please. And I did this afternoon, actually. I downloaded a little bit of data, which I'll come on to, from Scottish Government Remote Sensing, and had a look at, first of all, a series of known monuments. So Culmark Hill, you've got a couple of prehistoric roundhouses. At the bottom, you've got Glenlocha Roman Fort, which I've always assumed has been ploughed flat because we know about it from crop marking in arable crops. But clearly there is quite a lot of the fort and the line of the road cutting across the top of the image, quite visible in the surface topography. But again, that very subtle topography that is so difficult to discern when you're on the ground. And then Glenhool Hill, fantastic textures of the landscape, small clearance cairns, field boundaries, ridge and furrow cultivation, the fantastic palimpsest of people doing all sorts of things and reworking the landscape over hundreds of thousands of years. And that richness that's laid out in an image like that is to me very, very exciting. Next slide, please. And I then went and had a quick trawl around in between the blue dots, which represented existing knowledge. And within 5 minutes, I'd found this little ring bank. It's about 8 meters in diameter. What appears to be a field bank cuts across it. You can see that in the detail. You can pick out the slight extra bit of height where the presumably medieval, post-medieval field boundary bounces over this presumably prehistoric roundhouse. New discovery. Next slide, please. And this again, I've forgotten where this is, but there's a challenge there for you if you do start working with the LIDAR to find it for me. Here again, a point that is about that richness of the archaeological landscape that we're seeing. There's a post-medieval farm at the edge of the image, the pattern of globular fields, and more or less bang in the middle, you can see the cross-cutting pattern of two different episodes of cultivation. So this is about you're capturing that broad view, but you're also gaining these little insights into the different patterns of land use and activity 200-300 years ago. Next slide, please. It's great, but it's not magic. Okay, so that was the kind of message in here. And I wanted to go back into that point about things like canopy, close to ground vegetation like bracken, the time of data acquisition, and so on, all have an impact on what you're going to see and what you can work through. And that is something that we need to keep in mind all the time. Next slide, please. And it's also in places going to be pretty disappointing. As I said earlier on, quite a lot of the airborne laser scanning coverage in the south of Scotland was collected in the late spring and early summer. And that means that bracken, which is illustrated with these couple of images of the same area, is becoming a problem. And what you see in the hillshade in grey there is that actually there is a lot of noise which is produced by the denser clumps of bracken that basically stopped the laser pulse from getting through to the ground. And some of that will create noise that looks a little bit archaeological, more in the sort of upper middle bit of the airborne laser scanning image. There's a C-shaped feature, which I think back to front C-shape, which I suspect is just vegetation. But again, there's the potential for these kinds of things to mislead. Next slide. So very quickly, because I gather this will be available. Do you want to get started? What you need is a geographical information system. You need some data. You need to work with a visualization toolbox. You need to have an inquiring mind, and I've put back the cattle feeder bins on, and a critical faculty, because there is a lot of stuff on airborne laser scanning and aerial photography which is tricksy. It's there to catch you out. And I've been foolish enough with colleagues enough times in the past where I've got overexcited about something, switched off my brain, and embarrassed myself with my poor interpretation. So try not to follow me down that path. Next slide, please. So if you're interested, get QGIS. It's a brilliant open source piece of software. There are loads and loads of online tutorials. If you're reasonably computer literate, you'll be up and running at a drop of a hat. But you do need this really to work with, because it's a geographical information system and the data that you're working with is geographical information. Next slide, please. And courtesy of the Scottish Government, there is the map actually is slightly out of date because it doesn't have all the southern Scottish coverage. We have a remote sensing portal where you can load up, search for your area of interest, download the files, and you're ready to go. And again, a couple of the illustrations that I showed you earlier, downloading, visualizing, which I'll come on to, putting them into the GIS, kind of took 10 minutes for each 5 by 5 kilometer square. It's very, very quick. Next slide, please. And courtesy of our colleagues in Slovenia, we have, again, another piece of easy to use, free to download software called the Relief Visualization Toolbox, which is one of the best, simplest pieces of software that I've ever used. You literally upload your files, do a series of tick boxes, and hit start or run. And you also have on that website a guide to airborne laser scanning data visualization written by Giga and a colleague from Germany, which again explains all this kind of stuff, what it means. So again, free, open source, easy to use. Next slide, please. And there's also a lot of guidance out there. I mean, should I be recommending something that's published by Historic England? Yeah, no, I probably should. So this is the place to start. It's very good. It sets everything that you need to know to start with. and is a great intro to the topic, and again is available free off the Historic England website. Next slide, please. So part of the point of those preceding slides is that if you're interested and motivated, there's data, and it's not just Scotland. Large parts of Europe, big parts of North America have freely available data that you can download and play with. The other thing that I wanted to kind of recommend to people is really to have a look at a series of, and I've just picked up 3 that I'm kind of familiar with, but a series of fantastic community-based projects that have used airborne laser scanning data in a survey framework and working with local communities to really great effect. I mean, I can't say that strongly enough. And the examples of the Whitadder one with the AOC across in the eastern borders, the National Forest in England, New Forest, sorry, down in England, again, another long-running, very nicely sorted project, and a much more recent one in the Chilterns, which have got good source material, good explanations. In the case of the Chilterns, the capacity to get directly involved, and this is all really good stuff to have a look at. Next slide, please. And just a little bit of an advert on behalf of Graham Cavers at AOC, coming soon locally for those of you who are down in the southwest. There's going to be a Machers LIDAR project, which is looking at coastal archaeology around an absolutely gorgeous piece of coast. Why wouldn't you want to do survey work around parts of the Machers? Next slide, please. So what I really like about working with remote sensing data and airborne laser scanning is great. You never know what's going to pop up, and I'll give out a prize to any of you who find an elephant in the Scottish airborne laser scanning data. But this is an example. The elephant is a genuine example of a beast that was captured during airborne laser scanning. I mean, not in Scotland, obviously, but as a kind of random, unexpected byproduct of that process. The other image was something that Savannah Tudalong, who's an Edinburgh intern with us last year, picked up, and she sent it to me saying, "What do you make of this?" And I kind of cogitated it for quite a long time and said, "Yeah, I'm not really sure. I think it's in the vegetation, and I think it's recent." And this is an illustration of how slow my mental processes are, is that it was a couple of days later as she came back to me and she said, if you turn it on the side, it says no. And I did a little bit of chasing around, and this is quite big. I think the letters are about 30 meters high or in extent, and it's in the field circled in red there, which is opposite the ferry port. And the LIDAR data was collected in 2015, I think, late 2015. This is IndyRef, yes, no kind of stuff. And I think is for me is a really nice example of, first of all, that kind of, there's anything and everything in the data, and it's documenting our landscapes and our people and our what's going on from yesterday back into the distant past. And you know, that little bit of I don't know, vegetation graffiti or whatever you want to call it, is an important part of Scotland's history. You know, regardless of what you, which way you voted on that, and designed to be seen from the ferry. So let's say yes to LIDAR. It's great, it's brilliant, but it's not magic. A whole series of caveats, remember those, but go for it and work with it. And in here, for me, one of the really exciting things is that kind of smorgasbord of information that's laid out in these digital landscapes. And there's also then this question of how we combine the people, the computer algorithms, these different kinds of ways of looking to better understand our past and our landscapes. And with that, thank you very much for your attention. I'm happy to take any questions.
Wow.
Thank you.
Really, really good. I wasn't expecting that. I was expecting to rattle through the technology, but I wasn't, and the images, but I wasn't expecting to divert into training the AI with the dark web. That was fascinating. And I think for me as well, really interesting, Dave, how you said at one point, you know, we did this and it took us all day. And then 15 years later, it's the sort of thing you can do in a, you know, just by a passing scan. So that's one evolution of the technology, isn't it? But then you said, but it's not just about doing what we did before better. We now need to go into this whole new digital world and this digital realm and just try and visualize things completely differently and see what we can get from the data. Amazing. Really, really good. Right, I'm going to be, those of you who've been before will know that I'm, having said my thank yous, I'm going to be really cheeky and just share my screen again and just do a really quick overview of how to stay in touch if you've enjoyed this, and then we'll go back to questions because I know there's been some great questions coming into the chat. So I'll just go through this quite quickly, but if you've enjoyed this, you can follow us on Facebook and Twitter and Instagram. The Galloway Glens overarching one is at Galloway Glens, and Can You Dig It? Either search for Can You Dig It or GGLP Archaeology. Claire mans the Can You Dig It social media streams, and those of you who already follow us will know that it's just really a daily dose of lovely, lovely heritage goodness. So it'll cheer you up on these dark evenings. I do intermittent mailing lists. I'm due one will be coming out shortly. If you'd like to join that for more information about Can You Dig It, then email myself, helen.kerran@dumgal.gov.uk. There's a website, gallowayglens.org. We will put this up on YouTube. I know we've got a backlog, but I'm working on that. But it will come up on YouTube in time, and quite a lot of our other recordings are up there already. So if you've enjoyed this and missed the old ones, then you can settle in with a cup of tea for some of those. We've got 2 more to go this year. We've got a bit of fun coming up. We've got Haunting Tales from Mostly Ghostly in a fortnight. That should be a right giggle. They're a very funny bunch, the Mostly Ghostly team. Take us through a different slant on Galloway heritage. And then on the 2nd of December, as our sort of event finale, we've got some Viking tales from Olaf and Cathbad, if any of you saw those before. They've got the evening slot this time, so there can be a bit more blood and guts and gore and battles. So those will be fantastic. It's all free thanks to our funding from Historic Environment Scotland and the National Lottery Heritage Fund. So do just book on and come along. We've got a couple of ongoing projects about milestones in the Galloway Glens if you live here, or if you live anywhere in Scotland, updating Canmore, the National Historic Record for local buildings. So that's another way of getting involved. But I want to go straight back to questions because we've clearly got a lot of very interested and interesting people online with some excellent questions. I think we've got some experts in the room, to be honest, which I do not fall into the category of. Now, Dylan did say early on, Dave, and I thought it was actually a good question on that, but I don't know if you'll be able to remember, on the Scotland map, where you had southern Scotland and it showed how well that was mapped. It was all coloured yellows and greens. What were the key colours for that? What were the significance of the colours there?
I think they are essentially just trying to capture the gross differences in height. So you're probably seeing the kind of things like the Ken and Cree estuaries and so on. So I think it was just an attempt to show the overall topography. That was all.
Yeah, okay, yeah, brilliant. Question from Peter about images being available to the public, and then said cheap versions for drones. I think that might be 2 different questions because there's the finished images, aren't there? And then
yeah. Okay, so hi Peter. So yes, the Scottish Government Remote Sensing Portal is free for anybody. There's basic licensing, but it's the data is basically available under open government licensing. So I think that probably answers your question about the free data. It doesn't come as images, which is why I did that little bit about what you need to do to make. So that's one of the great things about some of these kind of community-based projects, is that they've created the web-based interface which anybody can use and access the images. So that's a kind of aspiration for the future. You can get a drone mounted airborne laser scanner, but it will cost you certainly a high 5-figure sum, if not a 6-figure sum. So pop it on your Christmas present list and see what happens.
Well, maybe on those lines, actually, somebody's mentioned that there's a LIDAR feature on the iPhone 12. Seems unlikely to.
Yes. Yeah, no. It doesn't have, I don't think it's really suitable for doing archaeological landscapes. But I mean, remember that autonomous cars, one of the main sets of inputs for those is our LIDAR systems. So it's one of the reasons why airborne laser scanning is becoming so much cheaper, and you can get them small enough to mount on a drone, is because of that kind of development where the basics of a laser scanner are becoming incredibly cheap and being used in all sorts of things, from driverless cars to whatever else.
Crikey, you just wouldn't have thought it, would you, even 10 years ago? Lindsay was asking, I don't know, I don't think you've answered this specifically. Can you download versions of the data with the vegetation already stripped out?
Yeah, so the Scottish Government site allows you, with some variation across different data collections, it allows you to download what's called the LAS file, which is basically the raw data, and you need to be a specialist user to get much out of that. It needs its own kind of basically proprietary software to process. You can also download the digital surface model, which is a digital surface model. So if there's a clump of trees, it's the top of the trees and then the ground. And then there's the digital terrain model, which should be by and large the terrain, with the vegetation stripped away. I would always recommend you to work with both, or at least have a look at them, because it gives you an idea of how well processed or how well the data has been filtered to remove the trees. The other thing to keep in mind is that, unfortunately, the publicly available version of the digital terrain model and digital surface model has had the data density reduced slightly, and that's partly about making it manageable, but also I think to do with the licensing of how they acquired it.
Okay, well, it's a good starter for 10. This was a good question from Di. Do you focus on areas where you think you'll find archaeology, or are you systematically grid searching?
So within the framework of the RAMP project, we identified 3 area surveys, which we tried to do as systematically as possible. We're now considering our next steps and trying to address 2 things. One is to define future survey areas, and we're going to be down in the southwest, in the New Luce and Rins area, hopefully in spring next year, but looking specifically at the scheduled ancient monuments. But one of the things that we're trying to scope at the moment is we've now got about 20,000 square kilometers of high resolution LIDAR across southern and central Scotland. How do we deal with all of that? And that's the kind of rapid searching that I was trialing, where I spent, perhaps a day on a 10 by 10 kilometer block. But it's great fun to trawl randomly around. But for our purposes, we do want to be as systematic as possible. So we have set, for example, grids to guide people scanning backwards and forwards with a preset number of viewing scales and so on, basically just to make sure that when we are looking at an area, we're doing it reasonably systematically.
Yeah, that makes a lot of sense. Joan said, are there any plans to investigate Westray? That's a particular interest. on Orkney?
Not as things stand at the moment. There's LIDAR data for West Mainland Orkney and the North Bit of Hoy. But as far as I know, there's no plans to fly West Stray anytime soon, unfortunately.
Yeah, fair enough. This is a great question, especially for around here. How effective is it in peaty areas?
Yeah, I saw that question. So as somebody else put into the chat, it doesn't see into the ground. Now, there's something called the reflectance, which is basically the intensity of the laser pulse that is bounced back off the ground, back up to the aircraft. And if you imagine you've got a very dark soil, it's less reflective than a shiny surface. So those relative intensities of backscatter going back up the way do provide some proxies for example, wetter soils as opposed to drier soils. And that can tell you about ditches or infilled river channels and so on. But otherwise, you're not seeing below the surface directly. And yeah, peat is one of those kind of big prospection problems that LIDAR is not helping you. There's some geophysical techniques which are trying to explore them, but it's one of the big black holes in knowledge in Scottish archaeology, really. And you look into Ireland or places like Ballachulish and so on, and the kind of stuff that has popped out from underneath the peat through drainage or what have you. And there's a lot of richness in there, but how to get to it is a conundrum. Answers on a postcard, please.
Well, especially when the peat is so precious to us, so as a carbon sink. So yeah. Fascinating. Yeah. Okay, lovely comment from Richard saying keep these going even when things are better. Yes, just as an aside, we're researching that at the moment. We really do want to do that. We're so pleased with the new audience that we're reaching. We want to go back to the town halls for sure, but we want to do it in parallel. So rest assured that we will try and keep this up. Right, people boggled by the AI, rightly so. Andy Nicholson pointed out that LIDAR is a black hole for productive work time. Yes, and then I think you did cover it with the citizen science. I think you did. We'll put the links up on Facebook. People are, some people are very keen to get involved with citizen science, but I think you covered that. Right, I'm just scrolling through. Have the Bathgate Hills been surveyed yet?
I think they've been flown as part or been bought as part of the most recent acquisition by the Scottish Government. Couldn't swear to it, but I think so. And so keep an eye on the Scottish Government remote sensing portal. I think they're progressively uploading stuff when they get it.
Oh, brilliant. Right, some great questions here from Donald, who's been super useful throughout the chat. Thank you, Donald. One, is LIDAR dangerous to eyes? Is there any restrictions on using it in urban areas?
No, so there's actually two related questions in the chat on that. So no, it's normal LIDAR is eye safe. And has been used to very good effect in urban areas. I believe there's quite good LIDAR for Edinburgh, Newtown and Glasgow, outside my kind of area of interest. And the same question was, sorry, I was just flipped up. You're asking also about how does the laser and the algorithm separate out vegetation from ground. The short answer is that a kind of hideously complicated piece of software does it. But to be slightly more useful, essentially the filtering, as I understand it, and this isn't my area of expertise, essentially does something where it will take the averaged last point from each laser pulse and call that ground. and then use that basis then to identify all the points above it as more likely to be vegetation or a building or whatever. So it's one of the consistent problems with general purpose LIDAR, and you'll find this if you start using the Scottish Government data, is that the digital surface models, they've stripped away all the buildings and all the trees, and it's been done overly aggressively, probably for archaeological purposes. So almost certainly some archaeology has almost also been stripped away.
Yeah, a reminder as ever that, you know, it's a human. The technology only does what we tell it to do. So
yes.
Yeah, it's very interesting. Lots of people asking about whether it can see through water into loch beds and sort of similar questions.
No, not the kind of LIDAR we've been looking at. And I don't know whether you remember, for example, there was an image with the Tweed running past, and you had this funny sort of triangle, big triangles cutting across, and that's basically where there's no data and it's interpolated. So this was also another question. There is the development of airborne laser bathymetry, which uses a green laser that does penetrate water. And again, the Austrian colleagues who I was drawing on quite a lot have done a test in Croatia where they were getting about 10-meter water penetration, which obviously depends on turbidity and clear water. So somewhere off a limestone coast is ideal. Churny, choppy water is not ideal. But yes, that's being developed, you know, because all sorts of other people are wanting the data. And I have a vague feeling that one of the issues with the green laser is it's not eye safe, so it's actually much more difficult to deploy.
Oh, fascinating. Dave Martin was asking what the density is in Scotland. I know you said that there's density you see and the density that's released.
Yeah, so it varies from about 1 point per meter to about 25. So all of the Southern Scotland stuff was collected at about 25 points in a meter square, which is amazing. That for public consumption has been decimated down to between 5 and 8 points, which is the resolution of, I think it's pretty good. I don't think there's massive compromises down to a little bit less than 10 points in a meter square. But always there's that kind of trade-off. If you try to work with the 25 point per meter square across an area that's 400 kilometers square, you've got massive data. So there's a balance in there. And I think most of the new data acquisitions will probably be in the order of the 10 to 25 points, simply because laser scanners have developed so much over the last few years that's the way they work generally.
Oh, fascinating. Yeah. People are interested and they're asking. I know you put up some links and we'll put them on social media, but is there Steve's saying, can the public help with analysing squares like they did for the Global Explorer project? Is there something the equivalent to that, or is it more regionally specific?
It would be nice to do that. We were hoping to do something with that. Yeah, very much on the Zooniverse Global Explorer type model. There's also a very nice Dutch citizen science experiment where they used, I think, the Zooniverse platform or similar one to do something like that. So yeah, no, short answer is no, but it is an aspiration of ours to try and get something like that up and running. And but it's also, you know, a lot of those community projects which I flagged up are also doing a great job in engaging people in that kind of activity. But yes, an incredibly important element of the work going forward.
I guess that's the benefit of this new digital world that we all find ourselves in, is that you know, it doesn't have to be a community near you. If you want to explore the technology, you can ship on and help somebody in Northern England or something. Brilliant. I think we're getting to the end. I did see there was a discussion about exploration of Pictish and Viking areas across Scotland, Angus and Caithness. Dave did answer, but is there anything else from?
There's not particularly good coverage for either of those two areas. The exception being the AOC project up in parts of Caithness. There's 2 blocks of data in the Yarrows and Bailey Hill area of Caithness, but otherwise it's a little bit patchy.
Okay, and then lastly, I think, sorry, that was the answer.
Good point about, good point about Gordon Noble's work at the Tapper North. People want to see a really nice example of data being deployed in a research environment. That's a good one to look at.
Fabulous. And then I think lastly, this is Kevin, are you able to incorporate LIDAR scans with other geophysical methods, GPR, MT, resistivity, to build subsurface models? And somebody else commented that is a massive bonus of the new sort of digital world that digital data that you can work in. But any thoughts on that, of combining it with other methods?
Yeah, no, absolutely. We've actually at HES just started to set up a very small geophysics capacity, and one of the things we want to try and explore is that kind of, I believe the catchphrase is data fusion. But yeah, this is seeing under the ground through geophysics techniques has increased in its capacity to cover large areas and to collect really detailed information, and has moved more onto that kind of landscape scale. So yeah, that kind of combination of techniques is going to give us really good information. John Pouncett down at Oxford has done some really nice work combining digital surface models and geophysics data, and I'm sure there's other examples around, but if you're interested in that, have a look at his work as a really nice example.
Great. Okay. Well, I think it does just remain. I mean, it's probably a bit funny for everybody not to have seen Dave, but I can assure you that he was there, and I think you can all be assured of his expertise in the subject. There we are. There he is, making a brief appearance. So thank you, Dave. That was fascinating. Really, really good. Absolutely love that. Significantly wiser than I was before about it all. So as I said, we've recorded this, we'll put it on YouTube. We will put further reading links onto the Facebook tomorrow for people who want to follow up on it. And also just for people who live more locally, we are planning, we're planning some more projects, some small projects. So there's exciting times ahead for the winter for Galloway Glens people, but we'll be keeping up the online offering as well. So lovely. All right. Well, I'm going to say a big thank you to Dave, big thank you to Claire and Rathmel Archaeology who deliver this project for us. They do brilliantly as ever. Thank you very much, and hopefully see you in a fortnight.